How are you doing? Welcome to live stream number 175. I'm a little bit early here. There should be a clock ticking down. If you're watching the recording, I don't blame you for fast forwarding another 3 minutes or so. We'll get started right on the top of the hour here. Hope you had a great Father's Day weekend. Like I said, it's Monday. It's June 18, 2018. Today's topic is how to set up and run a generative design project. So generative design is this new function we've covered in a couple of live streams that is available inside of Fusion 360. Actually, where you can now get the computer to start thinking for you instead of you have to put everything in. And I'm going to show you another example on that today and kind of like how you go in there and how we can actually start getting the computer to help us out. But like I said, a little bit early. See, we got David in here. Thank you, David. Tommy, good to see you again, my friend. I think it's been a while, unless I missed you in the live stream chat. Justin is here. Like I said, 2.5 minutes. The clock is ticking down, and we should be able to go here. We might have some thunderstorms coming through here in Western New York. Just check my light here. Suddenly got very, very dark. See, we got Nigel here. Eduardo, really appreciate you guys taking the time. This is just the reason I'm starting a couple minutes early. Just I wanted to have a chance to thank you guys for jumping in. We got people from the UK, people from Denmark. Absolutely appreciate all you guys jumping in here. Absolutely awesome. You guys are the best. This week we're gonna have a live stream today. Gonna have a live stream tomorrow, and then I'm gonna try to squeeze one in on Friday. What is happening is I'm going to Chicago for a generative design workshop. It's sadly, the class is completely full, so we can't take more people for this event. There's coming one up in Michigan, Detroit, Michigan, in a couple of weeks. So if you are interested in possibly joining one of these workshops, shoot me an email. My email address is down in the description area beneath. Talking about Detroit, we got Minnesota. It's not too far from Detroit, is it? Maybe, I'm not sure. David, really appreciate it. Ryan, thank you for coming and joining these live streams. Really appreciate it. Bernie is here. Really awesome. Really appreciate all you guys taking the time. Troy, happy Father's Day to you, man. Hope you guys had a good time. I surely did. I got all spoiled. What is absolutely awesome. Perfect. All right, South Korea. Ooh, that's awesome. You guys got a soccer match coming up, or did you just have one? I'm not sure. All right, there's all this World Cup going on. I'm having a hard time keeping up with the World Cup this time. Not quite sure. I saw that a couple of countries didn't do so well. But today is another project inside of the generative design. We just want to kind of like give you a peek into that. So with 10 seconds counting down, what happened to your subscribers? Did YouTube mess up again? I've had some issues. Okay, clock is at 0. I'm sorry if you fast forwarded. I've had some issues with YouTube that after a live stream has been processed, it takes a few minutes, then the audio gets out of sync. What means that I have to delete the actual stream and upload my own local copy that happens right now. So that's why maybe something seems a little messed up. I'm hoping YouTube fixes it. All right, enough of this. Let me just get rid of the clock here, and then we will get into today's topic. All right, let's see here. Hello, everybody, and thank you so much for joining me to live stream number 175. Today is Monday, another great week ahead of us. It is June 18th, 2018, and today's topic is how to set up and run a generative design project. Now, just let me jump over here and let me just quickly just talk about that. And that was not what I was planning on showing. Let me swap that. There we go. There is Fusion with this new interface and everything. So this is the part we're going to talk about today. Primarily what I'm going to talk about is setting up and talking about this generative design. Now, I have already done a few live streams about generative design. If you look down in the description area, you will find them. 149, we talked about the GE bracket. 166, we kind of talked about the workflow. So if this whole generative design is brand new to you, check those videos out. And after this one, and then hopefully you can kind of like put your whole thing, wrap your head around what all this is. But generative design is a new technology that it's what is called topology optimization with some cool add-ons on. And that's what I want to talk about a little bit today when we're setting this up. It is brand new for Fusion 360. You need to have the ultimate package, and you need to have the paid version to have it for now. I'm like the busboy at a restaurant. I don't really know. I don't get to make any decisions, and I'm not quite sure what the future holds for this. But hopefully, as it goes further on, it'll be available also to hobbyist users. I tell you the reason for it right now that it is for paying users. First of all, because it's brand spanking new, but actually also because there is some cost upfront for us every time people generate with it. So with everything else we've ever done, AutoCAD, Inventor, Fusion 360, we develop the code and here you go. But in this case, every time you hit generate, there's actually a cost on top of that. But that's maybe a talk for another day. Let's get into it. And I'd say you too, if you're not, if you don't have this, I would just lean back and kind of like just notice how this technology is changing and what is coming kind of in the future. So this is called the Alcoa bracket. This is a bracket also used in the aircraft industry. Kind of like has a low to lift things here, and it has a couple of counterbores here. This is a typical design that you will see, an engineering department, right? They, you kind of like get set up and says, all right, let's design a new bracket. You design a new bracket, and whatever is the best thing you can come up with. You maybe run it through some simulation studies that you also can do inside of Fusion. But primarily, to come up with this bracket, the design of this bracket, it takes brain power, right? It takes somebody who is probably smarter than me to kind of model something up like this. Now, generative design will actually take a design and will give you multiple options for better solutions. So it will not give you necessarily, and that's one of the things I want to show you today, it will not necessarily give you the perfect results. It will give you a slew of variation of this design that you can then pick from and kind of like make it your own, I would say. And I'm going to take 2 seconds to tell a little bit of a story, one of my favorite stories. Back in years ago, when our laundry soap was this granulated kind of thing, now it's like these small packages things. But remember back in the day when you were a kid, it was, well, you maybe still using it, like granulated different sizes. There's a big company in England who made this kind of stuff, and they had a problem with the nozzles always get clogged because this granulated soap were different sizes. And they had like some of the best engineers, right? Like this is a big company, had some of the best engineers out there working on this project, and they know about fluid dynamics and things like that. They were never able, spent hours upon hours, they were never able to solve this nozzle problem. A little bit of desperation, the company went to some biologists and says, hey, would you look at this nozzle problem for this granulated soap particles? And these biologists, they didn't know anything about fluid dynamics. They didn't know anything about, how this would kind of flow through. But what they did was they took what they thought so far was the best design of the nozzle, and then they took that one design that they thought were the best, and they created 10 variations of that. And then they tested those 10 variations until they found the best one out of those 10. They took that one, they made 10 variations of that, And they continue doing that over and over and over, taking the best one, make 10 variations, testing them out, and so forth. And of course, in the end, they solved the problem. They came up with the solution. And the reason I'm telling that story is because that's how I look at generative design. Generative design will give you these different variations, and then you can go in and look at them and kind of pick out what you think are the best one when it falls within these parameters. So I hope that story might help you. Hopefully it didn't confuse you. All right, enough of me talking in here. But the truth is that in normal engineering, you will have a bunch of engineers, handful of engineers, and they will come out with the best the best design of what they know of trial and error. But with generative design, we can now actually go in and have the computer look at those. Now, generative design takes a little bit of different way of looking at it. So this is the design that the engineers had come up with. And in the first video, and you will find the links in the description beneath. In the first video, I didn't have a part to go from inside of generative design, and we went through and we got something for the software. But in this one here, in this exercise today, we're gonna take this bracket and use that as an existing part for a better design. So today, on how to set it up, we already have a current design that we want to make better. Now, generative needs some parameters. The software needs some parameters to work around. And you will see here that I have this bracket here, and then I have designed some other parts that are going to be preserve and obstacles areas inside of this. And this is what's going to help the software define where it can put material and where it cannot put the material. So let me just explain that. So if I turn all these off again, hold down Shift, right click, and show hide. So this is the bracket that the engineers at Alco have used, and we want to find a better design from that. What we're going to do is we are going to tell the software we need a pin bearing. There's going to be a bearing right here. See, right here. That's where the load's going to be. They're going to be right there. They're also going to be a plate. So this is going to restrict the software that you cannot build anywhere where there's reds. Okay? Anywhere where there's red, I don't want you to build. That means that in here there's going to be some counterbores. So we actually have, let me just hide the part here. So we actually model up these parts of bodies that are where the screw's going to be. Okay? I'm going to have 4 of those. And this here is actually more as a, I don't know which ones to watch. I'm looking for them. There you go. These 4 here, think of those as kind of like where the tool need to get in. So all the red stuff is obstacle areas. We don't want the software to build anything here. Now if I just hide those for a second, then we have these other ones that are not red. And that is our preserve area. So this is actually where the load's going to be and where the counterbore actually going to be here. Just going to find them. I should have labeled these better. Bolt flange is actually what they're called, so I can probably find them by the name. There you go. So this here are the area we're going to preserve inside. We're going to tell the software preserve this. And then we're going to tell the other areas are areas where we don't want you to put any material, because we need those areas not to have any material. And then we're going to start out with this body. If this is a little confusing, maybe watch the couple of other videos that I've created. But you will actually see these parts here. If you're familiar with Fusion, this was actually imported as step files or IGES files. So you can bring those into Fusion and use them in here. I actually didn't model these up myself. I did that in the first video that you will find the link for in the description area. But just to kind of like reiterate, this here is the current design. that the engineers have all come up with. Then we have modeled up, or have created these parts or bodies. Doesn't make a difference. Anything here in blue are areas we want to tell the software we definitely need to keep. Anything in red is where we're going to tell the software you cannot build over these areas. With all this on the screen inside of Fusion, I am now going to go into the generative design function here. That took me a little while to get to that. I apologize. Now, generative design is going to open up here, and it's going to open up, see here on the screen, 1, 2, 3. It's going to tell us the units. And I think the first one I did was in metric. So let's run this one in inches. Hit OK to this. And you will see here it's going to open up our part. So this is the setup inside of generative design. Now, I said before, I use topology optimization as a reference. So Fusion generative design is topology optimization with some cool caveat on top of it. Because what topology optimization does is it looks at these parts and then it tries to make the most streamlined version. But generative will actually also take into consideration how it's going to be made, because parts have to be produced. It just cannot just be a fancy design. So in here, if you watch the first video, you will get a little bit more. I'm talking a little bit more about the menus and in here. But what I'm going to do different in this one compared to the first video is I'm actually going to use a starting shape. I'm actually going to use that existing part that the engineers have come up with. And I'm going to select that here, right here as the body, and hit OK. And just to make it a little bit easier, I'm going to go into the design space over here, and I'm going to hide it. So hit the little eyeball here, turn it off. So now, what this means is that instead of in ordinary, if you didn't have a starting shape, so the first one, sorry, I'm sweating a little bit here. It's hot in my office. And it got really, 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 really dark. We're going to get thunder here any second. If you go into, and you don't generate a starting shape, we didn't do that in the first video, the software starts out with kind of like a bulk of material. Now when we have a starting shape, it would actually start with that one and start developing on that one. So if you watch the first one, understand generative design, that I found down in the description area, and then you watch this one, you'll see that's one of the differences with this video. Now when we have this, then we have taken that existing bracket that the engineers came up with, and model that one up, or use that one. Now we can go in and we can start using our preserve regions and our obstacle regions. So again, I'm going to start actually out with the obstacle this time. So this is where we are telling the software that we definitely don't want you to build anything. So I'm going to click on this shape here on our 4 kind of tools for the counterbore. And there's also going to be, if I spin around here, right inside of where we're going to put the hook for this bracket, I'm going to select that and hit OK. That's going to turn red, and that will show you that that is obstacles area, meaning don't build anything here, please. Then we're going to go, and we can hide that. So I'm going to go to obstacle, hit the little eye looking at us. And then the last thing we only have to define is the preserve regions. Select that, and I'm going to select this area here. This is the areas we definitely want to tell the software. The counterbores, right? The screw's going to mount here, and where we kind of like going to put the loads for this part, and hit OK on that, and that turns green. That's kind of the setup for this in regards to the geometry. So we still are using Fusion or some kind of a CAD, of course, because I imported this as IGES, but we need Fusion to get into generative design. And I modeled up these either components or bodies, doesn't really matter, for that. So again, red means don't build there, okay? All right, let's get back to generative. With that, we're now going to put some constraints. We're going to tell the software where this is going to be locked down. And of course, for us here, it's going to be where these 4 screws are. So I'm going to hold down Control and select the bottom faces here of these screws and hit OK with that. That's all set on that. And then I'm ready to apply some forces to this. So I'm going to go ahead here, hit the forces load. Again, you can move the menus around here. I'm going to select a direction type that is the multiple direction in here. And all the loads on this part is going to come right inside of here, right? So just if I go back to Fusion here and hide all our preserved obstacle regions, here you will see the original bracket that the engineers came up with. All the loads going to be right here. So that's where we're going to apply them inside of here too. So I'm going to go to the front view so we can just look at it here. And we're going to start out by applying 1,250 force pounds. That's about 5,500 newtons in that direction. So pulling out on it there, hit OK. So there we have kind of like our first load case over here. Now the first load case is holding the constraints and the loads, and I'm lazy, so I'm just gonna click on this clone so I get another clone for another load case. I can go in and adjust the loads for that load case. Click the little pencil, and the next one here I'm gonna apply 665 pounds in one direction minus 662 in the other direction. That's about 3,000 newtons for my metric friends. So now you see on the arrow here how we're pulling down in it. So we're applying multiple loads to kind of resemble this bracket being pulled in. And we're going to do one last one. Click on the clone icon, so load case number 3. Go into the load here. Click on the force here. And the last one's going to be probably, you know, the biggest load case. What's going to be a minus 2,500 pound force, or about 11,000 newtons down on this bracket here. That here kind of give us the free load cases on this part. Now right now we're only looking at the preserved. If you just came in, we can also turn back on the obstacles. That is the area where we're going to sell the software you cannot build. And then of course I had this starting shape. If I turn on the obstacle and preserve, this was the current bracket designed by the engineers. When we have done that, then we can move on here. So we did constraints, we did loads, now the objective of this case here. And objectives really just means what are you trying to achieve? And this is brand new. So more is going to come in generative design for sure. Right now we can do minimized mass, maximum stiffness, and then we can apply a factor of safety. Now, in the previous live streams about generative design and about simulation, I've talked about factor of safety. Factor of safety is, in my opinion, the most important thing whenever you're talking about simulation or anything, and it's pretty straightforward. One, as you see here on the screen, means right when the part is going to break. So when the material is literally going to crack, that's 1. Just think of a scale. 2, that would mean that we are saying that 1 is when it's going to break, and we're going to double that. So we're putting in a safety factor where 1 would mean break, and 2 means that we have kind of like doubled our security. So normally you're doing 2 to 3. That's kind of normal. Maybe if you're doing an aircraft part, then you maybe go higher. But for most of the simulation, 2 or 3 is normal. So that's why we're going to leave this. The next one is manufacturing. And this is really where Fusion, the generative inside of Fusion is different than topology optimization. Because unrestricted, as far as I know, is what we would normally call topology optimization. Just shave away. But additive manufacturing means that now we actually also going to run, we're going to build this part as if it was built on an additive machine with the different build directions. And that means we can insert things like an overhang. So how much overhang material can we have? So depending on how you, what type of additive you're using, like a powdered material or kind of like more like a welding, you can set different overhang angles. In this case here, we're going to do 70. We're going to come back to this in later live streams for sure. Minimum thickness, I'm going to put 0.045. That is about 1 millimeters for my metric friends. So that's the minimum thickness we're telling the software is going to keep on this. Hit OK to that. And the next thing is materials. Click on that. And by the way, pretty cool. When I got in here today, looking in here, I didn't have this many materials, but new materials was actually waiting for me to download. So that's kind of cool in here. Be aware of that. You can also create your own materials in here. Now I'm going to go into the Netfab additive material, and I'm going to select some maybe cobalt chrome and some Inconel 718 and some titanium. And you know, the reason that I'm selecting different materials is actually because that is one of the cool things about this generative design. Normally, when you model up a part, or most engineers model up a part, you are normally already set on material. This gotta be, you know, whatever, titanium, Inconel, whatever it is, because you kind of have to make that decision up front. But now with generative design, we can actually try different materials. Why not get an idea about how the other materials work? So that's one of the neat things about this this generative design here. So I'm going to select these three materials in here and hit OK. And then one thing I didn't talk about in my last live stream on this is there is a synthesis. I think you said that's how you pronounce it. Down here at the bottom, I'm going to select on that, and that will actually let you choose how much computer power you want to use in this. And of course, that means how long it's going to take to calculate. Now, everything that is calculated here is calculated on the cloud. Remember that. So I can actually go down. Maybe this is just kind of like go a little bit on the normal, so it's going to go a little bit faster. Hit OK. And now I'm ready to hit generate. Going to give it some kind of a name. We're going to call this one live stream 175. Live stream. I can spell. Boom, boom. Yeah, thunderstorm warnings for upstate New York. It's hot here too today. So let's click save, and it gets ready for the project here. The little diamond jumps up and down. 1, 2, 3, and we get this coming up asking us to run this with the cloud credits. I talked about this in the last video. So running a study, there's some cost on our end. It's 25 cloud credits. You can buy more of those, of course. You actually get some when you already have cloud credits. Even if you're a hobbyist, you have cloud credits. But 25 is about 25 bucks to run a study. I'm going to click OK to that. And then you will see here, it's going to take a few minutes. It's going to send this study up to the cloud. And then it will actually start processing here in just a few minutes. And by the way, I really encourage you, if you have questions about this, set them in the comments area, and I will definitely absolutely do my best to answer any questions. Like I said earlier, just if you came in, we have almost 100 people in here right now, which is absolutely awesome. I appreciate it. This generative design, as it's running right now, you have to have the paid version of Fusion 360 Ultimate to get access to it. For right now, I can't predict the future. I'm going to an event, hosting a workshop in Michigan, I think in a few weeks. So if you're interested in that, find my email address down in the description area. And I'll definitely make sure you get some information on that. A limited space, of course. So the faster you go, it's going to be in Detroit, Michigan, Novi, Michigan. But again, it's for paid users of the Ultimate package. You're going to be the only one who's going to be able to use it. So definitely ping me up on that. Now you will see here as the screen has changed a little bit, it's starting to kind of calculate. You'll see we have a study one spinning up here, and it takes probably about 10-15 minutes to kind of go through with this. Of course, I'm not going to make you wait for that. I don't like to do this, but I don't like these cooking shows where I'm pulling stuff out of the oven. But I ran this one earlier, 11:30 a.m. as you can see here. So let me just go and open that project up and we can talk a little bit about it. Go to the Explore page and load up that result. So like I said, it maybe took 15-20 minutes to run. Now, I've talked about some of the things you can see in here in the past, but a couple of other things that I just want you to be aware of. So this was all the studies that we got in about 15-20 minutes. And you can actually start looking over here. So one thing I did, go back into Fusion. If we click on this one, I made this one as titanium. And if you right click, you can do that in here. If you right click on a body and you go in and apply the physical material for this part, you will see that I apply titanium on it. We can go in here, we can right click and we can say, all right, so what is the properties? And for some reason, Fusion shows the mass in 17-ounce mass. Again, my metric friends, I'm sorry. That's about a pound. So think a pound. Now, when we go back into generative, we can actually, there's some different screens in here. We can actually start filling down. So the biggest one was 1.4 pounds, which is actually heavier. But as soon as you get under 1, you will actually see that it starts filtering down. So now I know anything smaller than a pound is now showing on the screen. So that's one thing where we can kind of like filtering down right on the screen here and find out which one are the lightest in pounds. Now my favorite screen is this one over here. Click on that and it will show us the different materials. This column shows us the minimum factor of safety. Remember that we had like 2 as our target and these are all within 2.004. So all of these are within that. That's perfect. But then you got the weight going all in the other direction here. So again, we have the one right here showing us that the titanium ones are definitely, if you go over here and look at this one, we can see that we are at a mass of half of a pound. So that's half the weight. And we are effective safety of 2. So that's pretty good. Now you could of course go and start looking at some of the other versions in here. See, they're very close. So if we double click on the first one down here, we will get a view of this. And of course, this is not the finished form, but it's giving us kind of a look at this one. It kind of, and you see, it's not isometric. It ran 23 variations of it. You can actually grab down here and you can maybe take a look and see what does number 20 look like. So you can kind of go back here and get a good idea about, ooh, this I like a little bit better, has a leg on each side. So like I said at the beginning, this is not going to give you necessarily the best one. It's going to give you some different variations of it. So if we go in and look at this one here, ooh, that might actually be nicer to actually manufacture. This one don't have like 2 legs on each side. And again, factor safety is 2. The weight is half the weight. So this is really where some of the neat things comes inside of this. So different variations. There's this titanium one. I like to turn the stress plot on. That kind of like, it makes it thin. It creates a side leg. If we go back to variation 10 here, it kind of creates 2 legs on each side. Still factor of safety, we're about 0.7. Versus if we go in and look at this one, where it's kind of just sucked in the middle here. So it gives you an option to look at the different ones, look at the different plots, and you can do a lot of stuff in here. We're probably going to come back to other live streams where I'm going to go deeper into this later on and show you this. But I wanted to do a video on how to set this up and how to look at that. So you can go in here, kind of start exploring. How would it look with Inconel? Double click on that one. See, that kind of like has some different legs and different versions out of it. One of the things I probably should point out that I think is important is that over the next, it's hot in here. Whew. I'm gonna have to end the live stream. I'm sweating. This is too much work. that in the future here, it's going to come inside of Generative where it actually knows also if you're doing CNC milling. So if you have a 2.5 axis, 3 axis, well, probably not 2.5 axis, 3 axis mill, like a standard Haas or something like that, or if you have like a 5 axis, and it's going to build models that you can actually machine. The models we're looking at right now here are probably more, well, you know, I don't want to say that this is more considered for 5 axis or additive. I could definitely, well, I could, with a couple of setups, I could definitely do this on a 3 axis mill. I think maybe that's my challenge for Friday, huh? To model this part up. And what we can do, just to wrap this up, with this is we can save it out as a solid model and get it back into Fusion, and then of course machine it in there. But I hope this was helpful. I hope that if this was the first time you got to see the generative design that I have on my Fusion 360 in here, I hope that this was somewhat a helpful 30-minute orientation into that. That is all that I was planning on showing today. See a quick question in here. Am I planning on going to the UK? I would love to go to the UK. Actually, AU is in London, I think right now, this week. I would love to. I just need a good excuse to get to the UK. That is where I'm going to end today's live stream. In a couple of weeks, I am going to be in Michigan. There's also going to be something next month in Toronto, Canada. So for any of my friends, I'm going to give you some more information on that. Any of my friends near the Toronto area, we're going to have a Fusion meetup there soon, next month. In a few weeks, it's Know Why for this generative design if you're interested in that. If you think that that's maybe something that can make it helpful for your company. I'm going to do what I normally do. If you're watching the recording, thank you so much. If this was useful, thumbs up. If it was not, be honest, thumbs down. Love to get your feedback in the comments area. I try to answer them all. I definitely read them all. Absolutely appreciate it. And with this, I'm going to jump into the live stream chat and say hi to everybody who's watching that. Until the next time, have an awesome, awesome day. Take care, folks.